Good morning once again, and welcome to our chemistry class about electron configurations. Today's lesson, we will be focusing on writing electron configurations of different elements. And in writing the electron configurations using the orbital diagrams, we must follow three different principles so that it will satisfy the correct electron configurations. We must follow the Aufbau principle, the Pauli exclusion principle, and the Helm's rule. One very good example that was shown here is actually aluminum. So for aluminum, we need to find the electron configurations. We have here a table or a periodic table on the right side of our screen in which it's very useful in doing the electron configurations using this orbital diagram of the aluminum. So we will just try to find out aluminum in the periodic table. This is the aluminum. It is found on group 13. And then the first thing that we should do is we will occupy first the first energy shells or the lowest energy shells, which is in 1s. So this one, this will be 1s and 1s2. So I will have one up and one down. And then after helium, I'll go to lithium. So that is one up. And then beryllium, that will be one down. And then boron, here number 13, so one up, carbon, one up, nitrogen, one up. So the reason for that is we're following the Hund's rule, that in this energy level, all of these three sublevels have the same energy. So we will distribute all the levels first, or the electrons, each of these sublevels. And that's the time that we can start moving down here and there. So we already filled up the 2p orbitals, which contains 6 electrons. Now let's move on to the 3s, or the third orbital, which is the 3s. And then we have the move down. And since our aluminum is found in p orbitals, so we can have only one last arrow up. And that is now the orbital diagram of our aluminum. Now we will try to transform this orbital diagram or electron configuration using the orbital diagram in a standard form of electron configurations. So we can write that one as 1s2, 2s2, 2p6, this one, 3s2, this is it, and the last one is 3p1, okay, that one. So if you noticed, the last orbital or the last quantum number in which the electron was occupied is actually in the third quantum number. So in the last orbital or the last orbit, we can have only 3 electrons. Now, this is what we call as a complete electron diagram of the aluminum. Now, how to transform these electron configurations in a noble gas configurations? That is what we call noble gas configurations. So we will be including these all noble gases, if you can find here, all this in group number 8, and then just try to use the noble gas that is actually before the atom or the element that we actually studied. So here, the noble gas that is actually there is neon. And then before we reach to aluminum, what are those electron configurations? So we have here neon. So you notice that the electron configurations of neon is this is the electron configurations of neon. So instead of writing those complete electron configurations of neon, we can just simply rewrite square bracket Ne, and then just follow the third orbital, which is 3s2, 3p1. And that's it. That is this. The noble gas configurations of our aluminum and the complete configurations, electron configurations of our aluminum. Now, I want you to try calcium. Pause the video Write the complete electron configurations of calcium and also the noble gas configurations of calcium and fill out correctly the orbital diagrams. Thank you and have a nice day.